We start?
Yes.
Namaskar to everyone. Am I audible?
Yes,
Yeah,
madam.
morning.
Yes, ma'am.
Okay. Yeah.
Shubham, we can stop sharing the screen. Yes, ma'am.
So, yeah, good afternoon and hearty congratulations to the Principal Wilson College, DBT Coordinator of the college, Professor Shetty, IAPT Sub-RC 08 team, Professor Aluwalia ji and Professor Rekha, and all the team members for organizing this winter school, and which is on astronomical data analysis using Python. We had a wonderful talk yesterday in the inaugural session with Professor Rajmal Jain and a series of sessions on the basics of Python. And now, sessions in the morning by Mr. Pratik Bharve and Mr. Jigar Patel have been informative as well as engaging, including a session on AstroPy. It is my delight to welcome Mr. Pratik Bharve and Mr. Jigar for yet another session on data analysis on Python, which forms a very important session because data analysis is one of the important skills and that will help the participants very well. Both the speakers of these sessions have excellent subject experts, which will help to provide an engaging session. And the classroom is already ready with the enriching material for the participants. And it is very heartening to see that all the participants are quite engaged in doing all those things. And it will be updated for today's session as well. And participants can learn during the session and they can ask queries in the chat, and they can post their queries which will be answered in the due course of time. And again, welcoming our speaker today to begin the session, which is going to be yet engaging and yet exciting. Thank you so much.
Thank you, Mrs. Vandana, for the wonderful presentation. Introduction. So we'll just get started off with what we are going to cover today. So this morning, Pratik did a wonderful job in teaching AstroPy and what it can do, covering fits image file and those kind of things. So it's well worth your time to get dive deep into these kind of topics and figure out yourself what you are capable of when using those libraries. So for now, this session will cover what I'm going to teach would be curve fitting for probably about 20 minutes or so, and then I'm going to dive deep into pandas, which is very crucial for what you're going to do next in the session. So without any further ado, we can just dive deep into curve fitting and pandas. So I'll start by sharing my screen if that's okay.
Yeah, sure. Please begin. Thank you so much.
No problem. Just give me 1 second there. Trying to figure things out here. So are you able to see the screen?
Yeah, it is just appearing. We are waiting for it. Yeah, now it is there. Please begin.
Perfect. So with that saying, I'm going to open a new notebook here, and I'm just going to title this as the lecture 2. And I'm going to do this, maybe say curve fitting and pandas. So with that done and dust, we will start with curve fitting. So essentially, curve fitting would involve uh, building mathematical functions that describe the relation between data points. So it's commonly used for astronomical data, analysis, observational data, physical phenomena, so on and so forth. So key steps into curve fitting would be you define a function, say f of x is equal to x squared, that and then use a curve fitting algorithm to find the best possible parameters to kind of depict what the original function plots in the first place. So then we can also evaluate the residuals and the error metrics and those kind of things. So we'll start off with a simple example. So we import the basic libraries called NumPy as NP. We import matplotlib.pyplot as PLT, that is for plotting. And from SciPy, this is a new library which essentially deals with all the mathematical operations, scientific operations, and even classifications to some extent. So SciPy dot optimize. We have an instance called curvefit. So these three things, is the font clearly visible? Should I zoom in way more?
You can increase a little bit more.
Okay. Is this
Thank you.
visible?
Yes, this is fine.
So once we are done with importing the necessary libraries for this particular concept, we will start on by naming the key steps for curve fitting. So the key steps would be, let's go with numbered list here. So one is going to be define the model function. Two is going to be use a fitting algorithm to find the best parameters. Then evaluate the fit using residuals or error metrics. So these are the three initial steps that would help you to kind of get started with a curve fitting process. So let's just go with a simple example first, like a linear model. So how would a linear model work? So linear model is nothing but y is equal to mx plus c. So in this case, suppose we have a random distribution of data, but that follows a linear kind of line. So how would we do that? So we need to make a sample data first. So generating sample data. With that done, I'm gonna write sample data here as x data, and that goes with np.array, and let's just go with a list. So 1, 2, 3, 4, 5. And sorry, that is x data. And then y data is np.array, and let's just say 2.1, 4.1, we have 6.2, we have 8, we have 10.1. So when you want to plot x data, or maybe just scatter, not plot, I want a scatter plot of x data and y data. This is what it look like. Like effectively that would be a straight line. And plot, and then yeah. So I have drawn a line that connects each point, and effectively you can see that they're kind of a straight line. So let's pass a model. Let's make this a bit more curvy. Yeah, I think that should do. So yeah, we have this as our data. So we want a model that can roughly predict the outline of this data. So the trend of this data. How would we do that? So the first is to define the first step after generating the defining, is the spelling right? Yeah, defining the model function. So you create a function, say linear model, and
Sorry to interrupt in between. There is a request by a few participants to use the dark theme. Will that be better?
the dark theme. I've not used dark theme in the Jupyter notebook ever. I'm not sure how to
It is in the settings theme option.
Yeah,
code
it
mirror.
is in
No,
the
no, 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 no. On the
settings
top.
Settings
Setting
theme
first option.
theme. Yeah,
dark. Okay. Oh, that's interesting.
yeah.
Okay. Every day I
And
learn new things.
and a little bit of the previous commands alongside because some may not be able to write the full thing. So I think that can,
Okay.
yeah, yeah, that will be
Yeah,
really good.
perfect.
Thank you so much. Yeah.
No problem. So essentially I have like generated a sample data, X and Y, and then I have plotted it to see how it looks like. My next step is to create a model that can effectively approximate the slope and the intercept such that it matches this trend. So in order to do that, we have X, and in order to do that, we make a function called linear model, and we put this parameters like X, M, C, and return M multiplied by X plus C. That's the definition of a linear model. You run that cell and you come to the next cell, and in this cell you perform the curve fitting. So and in order to perform curve fitting, we need two variables which we will assign after using the function curveFit from scipy.optimize. So when you press Shift tab, here you can say F. So what does F stand for? F stands for function without calling that. So F equals our linear model function. But notice that I've not called this function, which is how it should be here. I feed in the data, so X data, Y data, right? So for practice, it's better to kind of use Shift tab if you're using Jupyter Notebook. Different what's that called? Different softwares have different shortcut keys. Like if you're using PyCharm, it's Control Q. If you're using Atom, it's something else. So see the documentation of what software you use, and eventually you'll get a hang of how you can, summon this when you want it to. And the next, yeah, so moving on, X data is going to be X underscore data is how we define X data here. And Y data is Y underscore data. And that's it.
Can you directly write X data, Y data without saying X
Absolutely.
data equal to?
Absolutely. But since I have defined F equals the first input parameter itself is like I've said f equals, that means if I do this, it's going to give me an error. Positional argument followed keyword argument. So this is not, if I do this, it works. But if I say X data here and Y data here, this works. But equals, like you cannot input like different parameters after you like inputted the initial parameter with equals to sign. You get what I mean? So that's kind of the gist of Python nomenclature here. Like every function, the keyword argument is always before then the positional argument. Keyword argument in the sense f is the key and linear model is the value. That's how you read the LHS and RHS
Okay,
in Python.
programming very top. What you are
And then,
putting for work.
right. So now the variable params is that gives us the best estimated value for M and C. So if I look at params, it gives me the value of slope and it gives me the value of C. And covariance would give me the variance, and I believe, let me check the documentation. Yeah, I believe, yeah, so the first element is the variance and the second element is the covariance for the intercept, and the variance and the covariance for slope. So when you want to simplify this down to different variables, that's how you do it. So params, you break it down into two variables, and then if you want to print the slope, that's how you do it. M, and then intercept C is going to be C. Yeah, just I want to round this off as well, so I'm going to use np.round to 2 decimal places. Same goes for here. And yeah, so that's the best estimate for M and C here. So when I want to plot the estimate with the data, that's how we plot it. So plt dot scatter x data, or yeah, I'll just copy paste this. It'll be easier that way. And then plt dot plot x data with linear model given slope and intercept, label fitted line with color as say blue. Now hopefully this works without giving me an error. Yeah, Let's put this middle line as say green, and I want the legend in the sense the labels. Yeah. So green is the filter line and blue is the data. And if I were to say one more example, let's go with a quadratic example. So an example of a non-linear data. We can use the same analogy. So we create a function. So quadratic, I'm just gonna write the heading down. So create the model and define quadratic model. Quadratic model is also this. So ax squared plus b plus c, right? And so it is multiplied by x squared plus b times x plus c. But I want to copy, paste, cut and paste this. X, a comma b comma c, and I want to return that value. So that's the definition of a quadratic model. Now we can generate synthetic data. So this random data that follows the distribution, the quadratic curve. So we can use linspace here because it'll be very cumbersome to type all the values in. So I want 50 values between -10 and 10. So how we do it? I use linspace for that. And then for y data, we have, say, some random value of a, which is 3, times x data square minus b, that is 2, times x data plus some random value of c, that is 5, plus some abnormality like randomness. I'll just put some randomness in the data. So we use np dot random dot normal distribution with a mean of 0 and a standard deviation of 10 with size as the same size as x data shape. So when you look at the docstring for np.random normal, LOC refers to the mean and scale refers to the standard deviation. So yeah, once this is done and dusted, we can copy the same code which we used to plot the first generated data and then run the cell and plot the second. So this is how the data looks like. And X would represent the markers X would represent the data points. If you have the strength to count it, there will be 50 points here, and it's all yeah. So what we want to do is just estimate this curve using the quadratic model. So how do we do that? It's the same thing. So you go with parameters and then covariance. covariance. Yeah, and then curve fit. You look at the docstring and you see that it needs a function f. So we already have defined quadratic model. And x data, we will say that as x data because we overwrote what x data was. And that's what we're going to use for this one. And then y data is also going to be y data.
Jigar, can you
Once,
show once the quadratic model? Just
yeah,
scroll up and
so that's going to be ax squared plus bx plus c.
yeah, that's fine.
Once this is done and dusted, we can call in the parameters. Notice that there are 3 values now. That is a, b, and c. And that's what you expect when you run a quadratic model. So in order to plot this again, we can copy paste the same code, and instead of linear model, we have the quadratic model. And instead of these parameters here, we have instead of m and c, we have a comma b comma c, and fitted curve. Let's just keep this as orange. Yes, why not? Yeah, I think that should work now. So when I plot this, it's giving me an error. So a is not defined, right? So I have not defined a, which means I have to define it here. A comma b comma c equals params. Should work now. Yeah. So you can see that the orange line has it's the model has found a good estimate for the original data, and it follows the original data very well. So you can do the same thing with polyfit. So I think it's called sci-fi also has polynomial fit. So if you have, let's say, for example, more than, like, the data is very irregular. So what you can do is make a polynomial fit to see there is a chance of estimating what that data would look like. I think I'll keep that as an exercise, or I'll put that as a documentation, because this essentially curve fitting and explaining how the curve fitting works is endless, and you can do so many things with that. So is it okay if I just go through
Yeah, sure, that
if
will
I
be
carry on
helpful.
with pandas?
Yeah. Yes, so can we take a pause at this time and see there are some queries in the chat and also some things which can be answered at this juncture before proceeding further, just for 2 minutes?
Absolutely.
Yeah, thank you so
So
much.
we have what questions do we have? Can you please share the lines before cell 7? Before cell 7, okay. These ones. Oh, I think someone has already sent that. If you have any questions, you can unmute yourself. Like, feel free to ask any question regarding curve fitting, so we all can look through it together. Diagonal terms are
What
variance
is
and non-negative.
covariance means?
Covariance is so I believe
I have just put it in the chat box what covariance means for people who don't know.
Oh, okay.
It just shows how interdependent the parameters are. High covariance means the parameters are not independently determined.
Right.
Covariance or also correlation.
Sir, also I have one more question, sir.
Okay.
Sir, if we run the same curve fitting for another time, will it give same value or it will be different value? So because the value shows that for this value, the input data will be fitted as a straight curve like that. So there may be another possible values to fit this curve, no, sir. Will it return same value or different value, sir?
So every time, let me check. That's actually a good question. So if I run this, say I'm gonna run this as parameters 2 and covariance 2. Run this and this is gonna be the same. But if I do parameters, sorry, parameters 2. Yeah, I don't think there would be any difference, I guess.
No,
For
I
the
think
same.
for the
In
same
case,
set, it should not.
yeah, but when the data is being created, I think randomly, then there may be, when you
Then
do
yeah,
the same fitting, then there may be changes because every time data will be different. I think so.
absolutely.
You want this
Vanda ma'am is
random.
correct here. Because every time I generate new random data, this is gonna run and this is gonna create random data set with X data shape. That's gonna feed into Y data. So every time I run this, the data is gonna be different. And when I fit this and run this cell, the estimates are different because the data was different.
Yes, sir. Thank you, sir.
Okay. Any other questions? How can we fit the residual of the fitting? How can you find the residual of the find the residual? I believe think so. Residual is nothing but I believe the residuals are say for example um, mm, just give me 1 second. So I think yeah, based on the I think residuals is nothing but the I think the what's that thing called? So we need y fitted values, and that is going to be a quadratic. I think it's the quadratic, is it? Yeah. Quadratic model with x data and a comma b comma c and s variables is going to be y data minus Y fitted. Y fitted, yeah. So residuals would be these, but if I want to plot these residuals, you plot with X data and then you plot residuals. Let's just say I want color to be red, and I'll put the label as residuals. Yeah, I want a straight line as well. So pld dot plot X data with np dot zeros like X data. So that's how you plot the residuals, and you find the residuals by subtracting the original data with the fitted values. Going to be, yeah, pld.x label. It's gonna be should be okay. Yeah. So pld dot y label is gonna be residuals, and I want y minus f of x, and that's gonna give me an error. So y label, there's no underscore. Let's put plt dot grid equals true, and this gives you a good plot fixed size of the residuals. So 10,7. Yeah. And just to get the values, you can use this residuals. Is that clear?
Show
What
that earlier command. Can you plot? Why that X data NP zeros is plotted?
Yeah, so I just wanted a line throughout x, but y equals 0. So we get a kind of a, like, if these points are closer to this line, that means it's a very good estimate. If these points are farther away from the y equal to 0 line, that means it's somewhat an okayish estimate. So you can see that at x is equal to 5, you can see the residuals are a bit farther away from y equals 0. That means
That np dot zeros is just to draw that blue line.
absolutely, yeah.
Yeah.
So it just gives me an array of zeros with the same length as x data. That's what it means.
And residuals also determine the efficacy of a particular model, that which one is going to be the best suited model. So because they are just estimating your differences between the given value and the fitted model. So I think you have answered majority of the queries asked in the chat. Participants can read about more on the documentation, try different types of data. They can also try different types of model in order to get hands-on on it, because it will not be, I think, more possible to accommodate more things into this, because session is ready for new things also. So we now proceed further.
Yeah, absolutely. So we'll start off with Pandas, which is very crucial for what you guys will be doing further on. So without
Yes.
any delay, we'll just start off with that. Is that okay?
Yeah. Yeah. Thank you.
No problem. So Pandas. So earlier today, I sent a CSV file on the classroom. I just want to know if anyone has got, like, anyone did have the time to kind of go through it and see what actually uh, contained in the files. So I'll just briefly import. Just go with import pandas as PD. I'm gonna import matplotlib dot. It's already imported, but just for uh, yeah. So step one is going to be loading the data. So how do you load the data? The nomenclature in the Python community, whenever you load a data through pandas, it's called df. Df stands for data frame, and df is a variable which you assign to when you read the file. So in this case, since I've imported pandas as PD, I press here and just give me 1 second. So I've run the cell and get rid of the empty lines and press tab here. You can see that there are so many functions and classes available, but out of which we are interested in CSV because that file was a CSV. So read CSV, read underscore CSV is a function in Python that enables you, user, to import a CSV file in that instance. You can see that there are so many parameters which are there, but don't be overwhelmed by these. All you need is the path of the data. So in this case, I think I've set my data to be, it's probably here, I guess. Yeah. So I go through the start. I say users, Astro, that is me. I want to go to documents. I want to go to GitHub. I want to go to Python Astronomy workshop. I want to go to data. And there we go. That's the full path. And this is what you're going to start off with. All you need to know is where the file is located. And that's all. So once you're done with that, you run the cell and you just press df and run it in a new cell. You get a brief view of what the data looks like. So at the end, you can see that the data has 7,269 rows and 8 columns. Column names are also presented in bold characters, and the index for each of the row starts from 0. to 7,268. So when you want to call, say, a particular column, so df and square brackets, inverted commas, that means a string value, and you can press tab here. So when you press tab inside the inverted commas, you'll see different options of the columns you can call. So I'm just going to call name. So it's going to give me all the names from index 0 to 7,268. And all of these refer to the names. So I'm going to copy and paste the description which I've already posted on the classroom over
For
here.
some of the participants, they are not able to download it as a raw CSV file. It is getting converted into PDF.
PDF. Let me see.
I think it's because it's not uploaded as a material but an announcement. I will try to upload it again immediately.
Okay.
No, see, typically on the phone, it will get downloaded as PDF file
Yeah, that may be also one of the reason.
because the phone will not have other this. So on Google Drive, it can be directly shifted, but if they're using PC, then that is possible.
Mhm.
Because I believe for me, it directly opens in Google Sheets from where I can download it as CSV. Will should we?
I will share it on WhatsApp maybe.
Okay.
Yeah, that will be quicker. Yeah.
Okay.
So just to recap what I have done here with Pandas, I've imported the Pandas library as PD. That is the common understanding of how you want to import Pandas as. And pd.read CSV, so read underscore CSV is a function. And all you need to do is get the path of your interested CSV, of the CSV you're interested in, and define a variable df and assign whatever pandas.read underscore CSV gives you. When you look into the variable df, this is what it holds. So like a nice fancy table with all the columns and all the rows which are in the CSV. And when you want to call a particular column, that's how we do it as. So if I want to call, say, cloud, so this is what the column cloud gives us. So just for the definitions of each of the columns.
If it is in the same drive, same folder, then you don't need to give the full path, right? So if it's, suppose it is on a Google Drive.
No, you don't know. So explanation of, yeah, so say for example, I'm just gonna copy and paste this on, let's go with sessions, gonna go with, so um, right, so now I have copy and pasted the CSV file on the same folder in which I have this Jupyter notebook. So in this case, all I have to do is put the CSV name. And it's going to do the same thing, because in home, you can see that. Are you able to see this screen?
Yes, it is visible.
Yeah. So you can see that CSV, cfis.csv, and this particular file is in the same folder. So in that case, you don't need to mention the whole path address. So once you have finished, importing data frame, you want to understand what the data frame is. So I have mentioned this in the classroom, but I'll say it again. Name is the unique identifier for any separate variable star. RA0 is right attention in decimal degrees. Declination is also in decimal degrees. Mode is the pulsation mode of the switch star. It has two values: fundamental mode and first overtone mode. Cloud indicates which stellar cloud the star resides in, LMC or SMC. W represents the apparent magnitude of the star, and log P1 is the logarithmic pulsation period in days, but it's base 10, not base E. VI represents the color index. Lower values indicate bluer, hotter stars, and higher values indicate redder, cooler stars. With that out of the way, we can proceed with analyzing our CSV file. So if, say, for example, you want to get the counts of values. So say mode. So what was mode? Mode was the pulsation mode of the sweet star. So out of 7,269 entries, I want to see how many fall into F and how many fall into fundamental mode and how many fall into first overtone mode. So how do you do this? I'm just going to comment. So find the value counts for each unique element in mode column. So this is how you do it. So value counts, and then you run the cell. This is what you get. So F has 4,409 stars that have fundamental mode, and then first overtone mode has, 2,860 stars are first overtone mode. So that's how you read it. Yeah, so you can practice this particular function with different columns. And then if you want to print just the head, so print the first few rows of the data frame. This is how you do it. So print data dot head. So sorry, not data, df. So this is going to give you the first 4 rows of the data frame. Why is this useful? What if you have, what if your data has like 100,000 rows or something like that? You don't want to use your processing power just to load all of that in. So in that case, you just do this, df.head. So you can get a gist of what the names look like, what the right ascension looks like, and what the color index looks like through this handy function. Then we have,
Sir, can I ask a small doubt?
yeah, go on.
Sir, what defines the count value for H, sir? Because this set contains 7,200, data. How it decides to only show 5 values? Why not 10 or only one? What decides the value, sir? or is it random?
Like
I
what
think he
values are
means
you?
the head, df dot head.
Oh, it just shows the first values, like the
First 5
starting
values are
rows,
default.
the first starting rows. Yeah.
So if you want 10, you can just type df dot head 10. If you put 10 numbers, then it will show first 10 rows.
Yeah.
So my question
So
is,
it is
what sets the default value to be 5, sir?
default is 5. It is coded in pandas itself.
Yeah.
Okay, sir. Okay, sir.
Is that okay?
Yes, sir.
Okay. The next thing is I want to check the basic structure of the data frame. So how do you do that? You print df dot info. Info stands for information. And you call, so info is a function and you are calling that function with no input parameters. So it's going to give you a list, a data frame of the column indices, the column names, how many non-null values are there in that particular column, and what type of object does the column represent. So in this case, right ascension and declination, you can see that they are float 64-bit objects, and name is a string, and strings are defined as object class in Python. So you can see that all the numerical values start with float 64 and all the string columns start with objects. So this is essential. Why? Because you get to see how much memory the data frame uses in your PC and what type of what type of data is present in your data frame. So you have 5 columns with float 64 and 3 columns with string type objects. Then the next thing is going to be I want the summary statistics. So summary statistics can be given by df dot describe. So this is going to take all the numerical columns, right? So we had 5 numerical columns you can see here, and it's going to give you the count. It's going to give you the mean. It's going to give you the standard deviation. It's going to give you the minimum. It's also going to give you the maximum and how many. So 75% of the 7,269 values fall below 5.2 right ascension decimal degrees. 75% of 7,269 declination decimal degrees fall under minus 69.94. So that's how you read it. 50% of the right ascension decimal degrees fall below 1.13214. So this is how you read 25, 50, 75%. Is that clear? Mm. Yeah, someone raised their hand.
Yes, Jatin, you
Uh,
can unmute yourself and ask.
yes, sir, I had a doubt. Suppose if I have a data of many stars, and now I want to find stars in a particular range, number of stars. So how can I do it? Like suppose 5,000 to 7,000 Kelvin.
5,000 to 7,000 Kelvin at a particular temperature, right?
Yes.
So yeah, so this is how you do it. So where is the temperature column?
There is no temperature column in this, but you can show filtering
Yeah,
how
yeah,
we
yeah.
filtered it in. using some other value like
Yeah.
Bayesian
For
identity.
magnitude, you can show
That is going to be W. Yeah.
W.
So I just want to briefly see. So I'm just trying to, yeah. So trying to get the plot. So it varies the major many
14 to 16
I
you can filter.
yeah. So I want values between 14 to 16. So in this case, this is going to be less than 16. Let's just go with less than 16. It's going to give you a series of trues and false. If the value lies below 16, it's going to give you true. And if the value lies above 16, it's going to give you false. So how do you get the elements instead of true and false? So you cut this entire thing and put df square brackets and put the condition inside this. That's going to give you the whole data frame, but it's only going to give you the rows where the condition is met. So you can see that there are 6,215 stars that meet the apparent magnitude less than 16.
So now you can use and the condition and
Yeah.
so greater than
So
14 and less than 16, something like that.
in this case, there is a function called df.loc that is locate, and instead of round brackets, we use square brackets for this one. And inside those square brackets, we use round brackets for conditions. And between those round brackets, we have this. So this, or maybe and, because we want two conditions to be satisfied. So the first condition is going to be df apparent magnitude less than 16, right? And the second condition is going to be df apparent magnitude greater than 14. So this is going to give you the number of rows that satisfy both conditions, less than 16 and greater than 14. So 4,676 stars satisfy these conditions. Is that clear?
Yes, sir.
Okay. Are there any questions? Please don't hesitate to ask me. We have, I'm just looking at the chats right now. I believe Pratik is answering most of them.
I think most are answered by now.
Okay.
I would like to add one thing, that these kind of data analysis and filtering finds a very important role when we are dealing with data as high as 1 lakh, 2 lakhs, even more than that. Some of the websites are able to give this kind of analysis in terms of other query tools like SQL, and Pandas is also a very, very versatile tool in this regard, because one can imagine that if the data is having 1 lakh entries, how would one do the filtering manually? It cannot be done. So here is the importance of these kinds of tools, and especially in machine learning and other things also, Pandas, I think, plays an important role. So it is a kind of skill which participants can practice a lot, which will help them in a lot of data analysis when we are talking about. So thank you so much, Jigar. We
Right.
can proceed further. Yes.
Okay. Yeah. Some of the students are asking about the 75%, 50%. Don't worry, in the notebook, which I'll give you after the session, I'll precisely mention what that stands for. So, yeah, you can just refer to the notebook after the session if that's okay. And for the histogram part, it's just I have represented there's this inbuilt plot function which is assigned to each column here, and I want the plot. What kind of plot do I want? I want hist. There can also be scatter, but scatter wouldn't make much sense for what we wanted to see. So it's just kind of a rough, quick code which gives me what I really want. That's the end of it. But I'll give you a good documentation and cover that up in the notebook after the session. Is that okay? Then yeah, the next thing would be as we discussed earlier, like if else condition and those things, but also filtering stars with certain conditions. So how do we do that? So we have LMC. I want to filter out the data only LMC cloud. Don't want that as, yeah. So data is DF. The condition is the same here. So DF, I want cloud, and from that cloud, double equals to, because we are checking if it's LMC, not assigning it. So once that is done, we have LMC data, and these would contain all the 3034 LMC stars that are in LMC cloud. So that's how you choose or filter out. And then we can also sort values. So sort the data by right ascension RA0. How do we do that? So sorted data equals data dot df dot sort sort values, sorry. And I want to sort by string RA0. So this is how the sorted data is going to look like. So you can see that the lowest right ascension is 0.33, and it goes all the way to 6.22. So you can sort, you can also do ascending false. So now it's going to put the highest value first and the lowest value to the last. If this is set to true, then it's the other way around, right? So that's how you sort a series, the whole data frame with respect to one series, one column. When I say series, it's analogous to column. And then we have creating a new column from an existing one. So in order to do that, let's go with say period. And it's going to be 10 to the power of df log log p1. Yeah. So when I go with the whole data frame, it's gonna give me a new column that has periods, right? And it will do the appropriate calculation and take log p1 into account. So that's how you make a new column from an existing one. How do you say, or how do you look at multiple columns but not the whole data frame? So look at multiple columns but not the whole df. So you can print df with 2 square brackets, and you can put, say, name. I want log p1. I want period. So it's going to give you all the rows with just 3 columns, which I have mentioned. Say, for example, we have additional data coming in. So adding additional data. So how do we add this in the existing data frame? We mention additional data with PD, and then there is a class called data frame. When you look at the documentation of data frame, you have data. So in this case, I'm going to go to the new line and I'm going to put a dictionary. Inside that dictionary, I'm going to put name as one of the keys. I'm going to assign the value as a list, and that list is going to give me all the additional star names. So I'm just going to copy paste a few star names. And this one, and I'm going to put an additional column called extra info, which is not present in the current data frame. So in this case, it's going to be a list again. And I'm going to put this as an interesting star. And I'm going to put this as a rare star. So this is the additional data you have that you want to add onto the existing data frame TF, right? So how do you do it? You say you create a new variable called merged data frame and assign that variable as pd dot. There's a function called merge. Now, if you call that function and you read the doc string, there's left, right, how you want to merge, inner join, outer join, those kind of things, on what kind of column do you want to merge on with, and those kind of things. So you can go to the Pandas website and then read through the documentation and figure out yourself with, a few dummy examples you made yourself that, okay, these kind of things do these things. So it's just a matter of practice and getting hands-on with it. And that's how you basically learn Python, I guess. Yeah. So you have a data frame, you feed that into it, and you have the additional data which you want to merge the data frame with. I want on to be name. I want to merge on name. So you can see the first 2 elements of the name are OGLELMC 002, which is what I have mentioned here in the additional name. And I have this particular star as well, the second star, which is 0005. For those, I have additional information retrieved from my telescope or wherever. And I want those to be assigned to this star. How do I do that? So DF and additional data have common column called name. So that's on. I want the column, I want the merge to happen with the name on. And how do I want to merge? I want to keep all the left, all the elements on the left of the merge function. So left and right, right? So I want to keep all the elements on the left, and I just want to add whatever additional information is there on the right data frame, which is the additional underscore data. So after I do that, I run this thing and I print this on. This is what I get. So you can see that the first element, the first two elements have now values inside this new column called extra info, and all the other values in that extra info are NaN, which stands for no values at all. So that's how you merge two existing data frames if you have additional data that has been added to your original data frame. So
Sir,
that's one way to do it. Yeah, go on.
can we do same thing based on a condition, using a condition? Like star having less than some value of W to be termed as interested. Can we do like that?
Like in the sense merge only if
Sir,
stars have something, is it? Like say apparent magnitude more than 16,
yes,
only
yes.
then merge. Yeah, you just have to filter out before you merge. So this additional data would have star names of those who have apparent magnitude more than 16, and you have the original data frame already. So now it's just a you can use the same code here, and it will only pick out the stars that have apparent magnitude more than 16. So just filter out before, like just put the names of the stars that have apparent magnitude more than 16.
But
Is that
sir,
okay?
if I have a big data, then how can I find, like suppose I have more than 60 stars, so
Hmm.
to do that, because it will be very big.
No, it's like just like he showed above, right? 14 and 16, we use filters. You can filter that and just extract the names of the stars, and that you can use to pass it through the merge command.
Yeah.
So we already did this. From this, you can extract just the name column, convert it into Pandas series, and that can be passed through the merge command.
So
So only those
essentially,
names will be added at extra info column. Rest will be NaN.
additional info looks like this. This is the data frame, a small one, but this is what it looks like,
Yes,
right?
sir.
Yeah. Any other questions?
Sir, how does the additional data got those right assumption and magnitude values, sir? We didn't give any inputs in our we defined function, no, sir.
Yeah, because I have asked pd.merge to keep everything which is on the left side. So left side in the sense, there are two elements here, right? And left is df, right is additional data. So I want everything on left, which is
So
why I
see,
did left here.
this is exactly like SQL left join. So in left
Yeah,
join, he has said that merge data frame on the name column and using left join. So left join will keep the name column and its data on the right side, and then just add an extra column with the data. So that is the left join logic in SQL, which is
If
similar
I
in
do,
Pandas.
yeah, if I do right, this is what it gives me.
Then it will delete all the other rows.
Everything except those two.
Yes, sir. Also, I'm asking about those values. For values are the results, like the right assumption value, the declination value, their mode of pulsation. How do they get those values? I'm asking, sir.
It is getting from the
They,
main data frame, DF.
yeah,
Oh, okay, sir.
it won't crop out other columns just because you said I want to merge with respect to name. It will keep that column. It will only crop out the rows.
Okay, sir. Okay, sir. Got it, sir.
Okay.
I had a question.
Um, yeah.
So won't there be already pipelines which actually could classify such data from the surveys that you're actually taking the data from? And how can you access those surveys? And the pipelines essentially, yeah.
Okay. So you essentially could um, filter out from like online websites where you get the data from. But just in case if you want to kind of just have it on the go, or you are doing something which requires you to edit or filter out in an automation process, this would be the thing for you. Else, yeah, just go for the websites which already do that for you because they use SQL queries, which are way faster than Pandas or Python. And as far as I know, I believe Shetty sir or Pratik would be the best person to ask about uh, where you get the data from for astronomical purposes.
In fact,
Is that okay?
yeah, the next week's entire sessions are going to be that. So every resource person will talk about that particular area from where to get the data, because for different purposes there can be various different observatories which will give you data.
Sure.
Absolutely.
Thank you.
So, sir, how much time do we have?
I think it is now 5 minutes are left. So if the major part of it is done, we can switch on to the questions which are left out in the chat. And
There will be a
how much
small
is
quick poll on that. So
okay? So we can first have a quick poll, and after
Okay.
that we can just have a look on. We can wind it up first, and then we can have a look on the
there,
questions in the chat.
let's chat. Let's discuss the questions from the chat, and then we can have the poll. No problem.
Okay, fine.
Okay.
So
So,
can we have yeah, we can have a look on the questions.
yeah. So someone asked, can pandas be used to analyze the fetch data too? Pratik, is it possible to use fetch data using pandas, or is it just AstroPy that does
Um,
that?
I don't believe. Maybe we can figure out to do it, but doesn't make sense to do it in Pandas. It's just dictionary, right? Key value set. So even if you try to do it, it will just be two columns. Better to do it in AstroPy.
Yeah, makes sense. What was the 25%, 75, 50%, and 75%? Yeah. So I'll just briefly go through it again. Yeah, this one, right? So I'm just gonna write that down again here. So tf dot describe. Oh, yeah. So in this case, 75%, I'm gonna type it here as well. 5%. denotes out of 7,269 stars, 75% of them have say apparent magnitude W less than 15.7. Does that, so 75% denotes out of 7,269, 75% of them have apparent magnitude W less than 15.7. That's how you read it. Is this concept understood? And you can just do it for other columns and other quartiles as well. What else? Giving data in tabular form, is that what pandas do? Essentially, yeah, and just it gives you a handy way to calculate different operations for the whole column. So say for example, I want, and let's put this in new. Oopsie. Yeah. So applying functions to a column. So how do you do that? Df dot say width, and I want to apply a function. So yesterday we found out that we can also use functions with lambda. I want x to be hello if x less than 16, or say interesting star if x less than 16, else maybe nice star. So for it's gonna iterate, apply function is gonna iterate through each of the elements in the column W, and it's gonna check if x is less than 16. If it is, return this, else it's a nice star. And I can make another column in df and assign that to this one. So let's just call this rough details. And when I run this and call the df, it's gonna give me a new column that tells me whether it's an interesting star, given that W apparent magnitude is more than 16, as less than 16, else it's a nice star. What else do we have?
Sir, what does x mean here, sir?
X is a dummy function, a dummy variable. So you can do P or you can do Q, and it's gonna work the same. It's just a dummy variable that is meant for iterating through each of the values in column W.
So each time the function iterates, the q will become the value stored in the w, like that, sir?
each time the function at its q will become the value of, of w. Yeah, perfect.
Okay, sir. Thank you, sir.
No problem. Anyone else wants to ask? Yeah, you can always unmute yourself.
Question.
Yeah.
Sir, how can we plot this data in a map, like using matplotlib or something? Can we plot the data that we got in Pandas?
Absolutely. So I'll give you a very quick example of how you can do that. Say I want to plot the magnitude versus the period. So magnitude versus period. How do you do that? So use the same thing, plt dot plt dot figure. I want the fixed size to be more, so let's just say 8,6, and I want plt dot scatter. So I want scatter plot of the data frame with period, and I want tf apparent magnitude. I want color to be color index, vi, sorry, and color map to be where it is. Just a few more things here. So edge colors, I want this one, and alpha equals, alpha is the transparency of those points. So let's just keep that as 0.3. I also want to put a color bar here. I want to label the color bar as VI, that is color index. And PLD dot title magnitude versus period of Cephids, and PLD dot X label as periods and days. PLD dot Y label W is the apparent magnitude, and so this one, and then PLD dot, I want the grid as well, so I want grid to be true, and then I want PLD dot show. So this is now going to give you a graph of period versus apparent magnitude, or apparent magnitude versus period, and it's going to give you a curve
Here you can
like
give
this.
that log graph. You can plot
Log
log
P1,
graph. Log.
log, okay.
Both logs.
So I can effectively use np.log10, and I want to copy this and do the same thing to apparent magnitude and put this there. There we go. So there is a negative correlation between the apparent magnitude and the days. So higher, the more the days, less, sorry.
Yeah, brighter the star is,
brighter,
more the
yeah,
period.
more the
So
period, yeah.
larger the star is.
And then we can also plot out quickly. I'll just copy and paste because we're running out of time, but Yeah, this is the spatial distribution of shepherds. This you can get from the data as well. So on the x-axis, right ascension, and on the y-axis is declination. You can play around with these things as well. Also, mode distribution across clouds. There is this one as well. So mode distributions would be the first overtone is in purple, fundamental mode is in yellow. So SMC has more fundamental tone. There are stars which have more fundamental tone than LMC. We also have something more similar to hot spring Russell diagram. That is this one. So all of this is from the CSV data which we have, and on the x-axis it's color index, and on the y-axis it's apparent magnitude. The color is now dependent on which type of cloud it is. So I mapped LMC to purple and SMC to green. And yeah. So the brighter
What is mean by plot GCA in that code, sir?
plot GCA means get current access. So I want to get the current axis and I want to invert that only the y-axis.
Okay, sir.
Yeah. So yeah, you can kind of do all these things very effectively.
Sir,
I think most questions are answered
Yeah.
in the chat.
Okay.
Yeah, most of the questions are answered, and with that, we had an excellent session which was engaging and informative, and this can be gauged by the questions asked in the session. And the curve
Absolutely.
fitting and working on the pandas are form integral part of the data analysis, and that was demonstrated very beautifully by importing file, defining functions, from defining functions to plotting, and the tweaking the data in the desired format. Whatsoever is requirement can be tweaked by different functions like sorting, merging, and adding columns. All that can be done, and there is a plethora of information available, and one has to master the syntax and play with the variety of data, and the mantra will be practice and practice, and some of you are already practicing alongside. That is commendable. And thanks to Mr. Pratik for answering the queries alongside. And thank you so much, Mr. Jigar, for a wonderful session. I think participants have gained a lot out of it, and it is going to be more and more practice they do. I think more and more better it will be, because some may be novices, some may be in the intermediate level, some may be advanced learners also. But the kind of questions which are being asked are actually showing the engagement, and that engagement is beautiful. So thank you so much for the session. Thanks a lot. Thanks to all the
Yes,
participants and all the
go for
team
the
members also.
no, we go for the poll.
Yes,
So
poll
I'm just
is going to be here. Yeah, poll is going to be here. So don't leave before answering the poll. So one is having yeses dominating. Around 100 people have responded. So we have 210 participants, and it is expected that everyone is going to answer the poll. We have got 165 answered till now. Everyone is requested to answer quickly within the time limit. And these are quite very, very simple questions.
Okay, we'll end the poll in 10 seconds.
Yes, so it is going to be ended in 10 seconds now.
Okay, thank you.
Thanks a lot. Yeah.
Perfect. Thanks everyone for attending the session. And Vandana ma'am, you summed it up very well.
Thank you so much. And I think it was an amazing session. It will really help indirectly or directly in many ways. So we request the participants to get hold of the data, try to work on it, and I think you will gain a skill which is going to be lifelong.
Absolutely. Looking
Thank you,
forward to
ma'am.
hearing questions.
Yeah, so we end the session.